Just a quick check in the audience. Who here defines themselves as technical? Hands up.
And that's it.
All right, and hands down. Anybody here self-declared non-technical? All right, cool. The next talk we have coming up is a technical talk. Let me just get the name of the talk up for you guys. All right, Understanding EIL, a deep dive with Shahaf Nacson, who I think if you are not available, oh, you are over there. Hey. All right, awesome. Well, this is a man that needs no introduction, but a wonderful EF researcher, and he's going to deep dive on EIL with us. Everyone give a big round of applause while we call our speaker up. Ooh.
Thank you. Hi, so that's a good picture of me. So right now I'm going to do more of an overview of the system and the main flows, and not as deep dive as I wanted it to be at first, but this is the first time we introduced the protocol, so hopefully it will be more understandable that way. So some of what I say will be overlapping with what Yoav said, and that's okay, but hopefully I will focus right now mostly on the flow itself and bring it up to more concrete terms instead of the high-level goal and the vision that Yoav presented earlier. Okay, so that is not updated. Alex is sitting right here. Okay, so what is EIL? So as we wrote here, EIL is an on-chain protocol that allows you to seamlessly interact with the Ethereum ecosystem that is mostly L1 and L2s, which we wanted to bring in order to defragment the currently very highly fragmented network that we currently have. Because as opposed to 2015, where we only had, or 2016, where we only had Ethereum and all of the dApps, all of the interactions were with one chain, right now, if you want, as Yoav also showed in his example, if Alice wants to send 100 USDC, she needs to know that this USDC, for example, is on Arbitrum. And if she wants to send it to someone on Base or on Optimism or another network, she needs to know all the details, and we'll see soon, the way I explained, that there are a lot of friction involved inside of it. So an EIL just is the on-chain protocol that allows you to seamlessly interact with the network. Now, it is built on top of 467 ecosystem, so we bring all the good things from 467, including gas payment and abstraction with paymasters, which we also utilize here. And the main features that we introduce right now is cross-chain asset transfer and multi-chain execution. And of course, as I said, cross-chain gas abstraction. Okay, so compared to 467, where you can use a paymaster to pay for a transaction on one chain, here you can use a paymaster to pay for a transaction on all chains. Now, what EIL is not, okay? It is not a DeFi protocol. We have no governance, no token, okay? We don't have any validation, any validators. We just enable seamless cross-chain DeFi interactions. Okay, so I think that we complement DeFi protocols very well. And what it is not as well, it's not an intent framework, as you have suggested as well, okay, because that was brought up, so we decided to preemptively state it here. Okay, this is not an intent framework. We don't solve any user wish into a transaction. We rely on the wallet to already know exactly what it wants to do. We just bring it the tools to do it seamlessly for the end user. Okay, so we think that actually we work very well as a backend, or as you have said, as the transport layer for any solver framework. Okay, and so what's good about EIL? Why did we decide to work on it? Why did we decide to introduce it when there are already some type of solutions that overlap, at least in terms of functionality, with what we do? So EIL, as we implemented it, is private. That is, communication between parties are only done on-chain. Okay, you don't need to expose anything else to a third-party solver or to any external service that you use. Okay, all communication is done on chain, and no need, which is the difference, the big difference between a solver and an intent framework to what we do. No need to reveal user actions on either chain. That is, if a user wants to perform an elaborate swap or buy an NFT, that is not exposed to the liquidity provider that we will introduce here. Okay? He doesn't know any action that the user does except for the cross-chain asset transfer that the user explicitly wants to do. For example, moving 100 USDC from Arbitrum to Base or Optimism. Okay. It is trustless because it is self-custodial. The user doesn't rely on any solver to benevolently send it the funds on the destination chain if it wants to transfer the funds from the source chain to the destination. So it is self-custodial. The user never relies on such server. Okay, and because of that, because there are no intermediaries, it works very well with censorship-resistant proposals such as Fossil. Okay, and the last but not least, it is decentralized. As I said, no trusted third parties, no fast bridges, it just works. Okay, so how Ethereum feels like today. Suppose Alice, I'll elaborate more on, I'll extend what you have already said as an example. Suppose Alice wants to send 100 USDC on Arbitrum. Okay? She has 100 USDC on Arbitrum and she knows it. Okay, it is very much, she is very much aware of the fact that this USDC sits on Arbitrum. Suppose Alice wants to buy an NFT for 90 USDC on Optimism. Now, what Alice needs to do, and that needs several transaction confirmations and a lot of UX hurdles involved. Okay, she needs to find an Arbitrum to Optimism bridge, and unless it is a fast bridge that has its downfalls as well, she needs to go through the full fraud-proof window that is 7 days in order to send a message from Arbitrum to L1, and then from L1 back to Optimism, okay, to Optimism, in order to send an actual message, even for the simple asset transfer of 90 USDC from Arbitrum to Optimism. Now, the first transaction that she needs to do, suppose she found a fast bridge, she needs to approve 90 USDC to the bridge. That is already the first transaction that Alice needs to do. The second one is an executing of the bridging and waiting for patiently for the benevolent bridge to also relay the message and release the funds on the destination chain. So what happens if the fast bridge is hacked or simply doesn't work, malfunctions? Alice loses its funds. Okay, the same goes, and this is another pain point, okay? The same goes for native ETH for gas payment, because what if Alice was already only working on Arbitrum because her wallet supports Arbitrum mainly, and this is where all her assets are. So she needs to do all of that also for native ETH. Okay? And then after all of that, okay, she needs to go back to the NFT market on Optimism and sign the transaction over there, which is already at least 4 transactions, and that is a very optimistic flow. Now, compare that to how EIL feels right now, okay, the way we implemented it. So Alice uses an EIL-enabled wallet. That is just an EIL wallet that uses our own SDK and goes through our own EIL contracts on-chain that we will see soon. Okay, she has 100 USDC. She doesn't care that it is on Arbitrum. She doesn't care where it is. Okay, it happens to be on Arbitrum internally. Okay, and Alice wants to buy an NFT for 90 USDC. Again, she doesn't know and doesn't care that this NFT marketplace is on Optimism. She just clicks one button to sign all of the transaction, confirms once, and it just works. That is the goal, and that is how it is currently implemented, as we'll see. So, the first thing about how EIL works, I would like to show you, is the entities involved. Before we dive into the actual flow, I want to show you how, what entities are involved and explain a bit in order to set up the terminology. Okay, so the first one is the cross-chain paymaster contract, okay, which is a paymaster in the 4367 sense that is on the destination chain. It is abstracting the gas from the user. Okay, so in our case, because Alice works with 100 USDC and behind the scene the 100 USDC is only on Arbitrum, and she doesn't happen to have native ETH or USDC on Optimism, how would she pay for gas? That is where the cross-chain paymaster gets into play, and we'll see in the flow that the cross-chain paymaster is paying for the gas on the destination chain. So Alice doesn't need to go through all of that, also for the native ETH. Okay, so it is deployed on each chain that is supported by EIL once, just like entry point, that is a singleton contract, no need for more than one. Okay, and it acts as an XLP, which I'll elaborate later. This is the cross-chain liquidity provider that I'll explain right in this presentation. Okay, it acts as an XLP registry, the cross-chain liquidity provider registry, and deposit manager. Okay, which handles the deposit both for the liquidity providers and for the users to get on the other side, on the destination chain. Okay, it acts as I said, as a paymaster on the destination chain contract, a paymaster in a 4337 sense. Now, the second contract involved is the L1 stake manager contract. While you can register a liquidity provider, and it is permissionless, okay, anyone can register a liquidity provider, still it needs to be staked. Now, it's worth mentioning that the stake itself is, as we'll see soon, is fixed, and it doesn't grow with the amount of liquidity that the liquidity provider wants to provide. The third entity that we have is the cross-chain liquidity provider, as I said, the XLP. That is just a very simple server. It listens to events on the destination chain, on the source chain, and afterwards it just it accepts the user's request to move funds, to transfer funds from the source to the destination. Okay, as I said here. Okay, so what we call for the user when Alice wants to deposit 100 USDC or 90 USDC in order to withdraw on Optimism, and she wants to deposit it on Arbitrum, we just call it a voucher request. So she requests a voucher in the cross-chain paymaster, and the liquidity provider listens to this type of voucher request and issue vouchers that can be redeemed on the destination chain. Okay, as I said, anyone can register. Okay, the last component that we have that is both on-chain and off-chain is the EIL empowered wallet and smart account that is 457 smart account. Okay, okay, that's as I mentioned before, and that's it. So it's worth noting that while the smart account itself, both on-chain and off-chain, preferably would have some type of extensions that we provide as extension to its functionality. These extensions are not mandatory, but they are highly recommended in order to achieve the full UX that we wanted to give the users, the end users, in order to benefit from EIL completely. Now, so let's go into the actual flow of how it works. Now, the wallet builds two user operations, one for Arbitrum and one for Optimism. Okay, these are ERC 457 user operations. I assume that many of you already know what 457 looks like, so it's a we rely on that heavily in our system. Okay, as I said. The wallet locks 90 USDC deposit on the Arbitrum EIL contract, that is the cross-chain paymaster. And afterwards, the wallet gets, as we said, we call it a voucher request. The wallet waits for a liquidity provider to issue a voucher, and the liquidity provider that we just mentioned just sees the voucher request. There is no communication between the wallet and the liquidity provider outside the blockchain itself. Okay, so it is a very simple server. Okay, anyone can run it, even anyone can develop it from scratch. It's very simple, and anyone can run it locally and on Google Cloud, on Amazon, or whatever cloud you're using. Okay, so the last part that the wallet does after it sees that the voucher was issued on the source chain. So Alice wants to send 90 USDC from Arbitrum. She asks for the voucher on Arbitrum, and the liquidity provider provides the voucher on Arbitrum as a source chain that can only be redeemable on the destination chain, that is Optimism. Then the wallet sees this voucher that was signed on Arbitrum, it takes this voucher, appends it to the Optimism user operation, and sends it, and that's it. Okay, once the user operation on Arbitrum is submitted, first the user operation withdraws the funds from the cross-chain paymaster on Optimism, effectively releases the funds for the transaction, and then Alice can batch inside this user operation the next operations that she wants to do. In our case, just buy an NFT on Optimism. That's it. Okay, so we left some things out in this flow. And one of the things that I wanted to mention here is how EIL manages gas on the source chain as well. Because while I said that the cross-chain paymaster acts as a paymaster on the destination chain, it pays for the gas for the user transaction, what can be done on the source chain? And this is actually very simple. Because we're heavily using 457, any paymaster that is already out there is deployed, and any paymaster service can be used to provide gas abstraction on the source chain. Okay? Now, it's worth noting that because Alice doesn't necessarily have any asset on the destination chain, she might not have used it any time before, then the gas cost for the destination is actually being paid on the source chain. And she can choose even with what asset she's going to pay it. She can even choose to use native ETH on the source chain to pay for the transaction gas cost, and then send USDC, 90 USDC from Arbitrum to Optimism. Now, this enables fully cross-chain gas payment when we talk about the fragmentation of the ecosystem. You can do it not only for one source chain and one destination chain. You can actually batch many source chains and many destination chains and pay for the transaction with any token that you want on one source chain, as long as there is a paymaster that is willing to support the token. Okay, and again, that is not our paymaster. That is already existing paymasters that are out there for 457. Okay, on the destination chain is quite simpler. Okay, the cross-chain paymaster is the one that is paying for the transaction gas cost, and it is being done by appending the voucher to the user of paymaster data on the destination chain. The paymaster just checks the voucher is valid because the liquidity provider is registered both on the source and the destination chain. It checks that it has enough solvency, enough deposit, and just charges the liquidity provider for the user gas cost on the destination chain. Okay. This is the flow as we see it, the main flow that we talked about, and we can see it here as the flow diagram that I am showing right now. And it's basically describing what I already said. The wallet account first prepares the two user-ops for the Arbitrum and Optimism, just deposit to the Arbitrum EIL paymaster the 90 USDC, that is the voucher request. The liquidity provider listens to these voucher request created events, and once it sees one, it issues a voucher for 90 USDC plus the gas fees that is going to be paid on Optimism. Once the wallet sees that the voucher was issued, it takes the voucher signed from the voucher from this event and just submits the user up with the voucher on the destination chain. Okay, and it can concatenate as many vouchers that it wants. It can collect as many vouchers that it wants. For example, for more elaborate schemes, if you want, for example, to have different type of swaps from source chains to different destination chains. And I think that the major feature in our system in this case is that, again, we don't provide any information on what is actually being done aside from asking the liquidity provider for the voucher request. It doesn't know the user action outside of that. You can just append batch to both on the source chain and the destination chain any generic action that you would like to perform. Okay, so the one thing that we didn't discuss right now is the XLP registration, that is the cross-chain liquidity provider registration. And this one is very simple. I already mentioned it, but I'll repeat it again here. So the way it's being done is the liquidity provider decides which chains it wants to support. So it transacts on L1 stake manager. Okay, it just provides the information, all the chain information for all the chains that it wants to support once. Okay, and the chain information, it's mostly the chain ID, the paymaster address that it supports on the destination and the source chains, and of course the bridge that it would authorize in the case of a dispute resolution that we are not getting into right now, but we will discover later in the workshop. Okay. Now, as I mentioned, it needs to lock a fixed amount per chain. Thus, this amount is fixed. It's not growing with the liquidity providing the liquidity that is provided by the cross-chain liquidity provider. And I think that this is also a pain point that we solved, that the staking in the system doesn't explode when the system grows in liquidity, which grows much faster than the number of chains the liquidity provider wants to support. Now, as I mentioned, this acts not only as registration, but also as an authorization for the EIL contracts, the paymasters on these chains, and the bridge, the canonical bridge that it's using to perform operations in the case of the dispute flow. So it acts as an authorization for these contracts to perform the dispute resolutions on L1, in the L1 stake manager. Okay, so L1, once it gets the transaction, it broadcasts the LP information, the liquidity provider information to all EIL paymasters through the canonical bridge. Because it's a transaction from L1 to L2, there is no fraud-proof window, it happens immediately, and that's it. Now the XRP is ready to listen to events and is allowed to issue vouchers and participate in the network, and that's it. Now, so we touched briefly, as you have mentioned before, what wallet extensions we want, and as I said, these wallet extensions are not mandatory, but they are highly recommended in order to support the full flow, that is signing once on all chains, getting the full gas abstraction, and supporting the full EIL experience, as we mentioned, compared to the current fragmented networks that we have on all chains. So the first one is 5792 extension. That is wallet calls API. If anyone here is a wallet developer, they are probably aware of the wallet send calls API. That is the abstracted layer in the wallet for dApps to allow dApps to send multiple actions for the wallet to perform on whatever chain that they are using. So we are extending wallet call capabilities specifically for EIL. That is a natural extension for that. The second one that sounds very elaborate, but it's really not, is smart account runtime parameter resolution, which namely means that what if you don't know how much value you want to move from the source chain to the destination chain? Okay, what if you want to perform a swap? Then take the resulting of the swap, the resulting amount of the swap, and then move that to the destination chain. We also support that, but the smart account needs to also extend this functionality with what we already provide. Okay, so we have this functionality implemented for the smart account module to install, but this is mainly if you again if it wants to support dynamic values like that. Okay, this is what I mentioned. Now, the third one is the multi-chain user operation hash and signature, because if the smart account isn't using that one, then it means that it needs to sign repeatedly for every action that it does on every chain. Okay, interoperable addresses you have mentioned before, and advanced topics for the workshop, as I mentioned. Okay, that is okay. The runtime parameter resolution we will mention in the workshop. Okay, what if we don't talk the exact amount? The session data that we didn't mention here out of time, and the dispute mechanism. We'll dive into that a little bit more. What happens if the liquidity provider is insolvent? What happens in case of a chain reorg? What happens in case of civil attacks against the liquidity provider, and how we handle that part? Now, running an XLP, also we're going to show briefly in the workshop, because it's actually very easy to run an XLP in the system. Okay, and last but not least is the liquidity provider discovery and selection that is done from the client side. Okay, in our SDK, how it works. Okay, and that's it. What's next for EIL? Okay, it's just the SDK is already public. Okay, we are working live on multiple testnets in Sepolia, and thanks to Tenderly team, we are live with DevNet that is designed for the hackathon right now. And we have a wallet integration live thanks to Empire. And last, we have the bundlers live, the ERC 457 bundles that support the 0.9 entry point version, thanks to Etherspot. That's it. Just get in touch with us.
Thank you so much, Shahaf. And we don't, unfortunately, have time for Q&A today. There were a lot of really good questions. We do have a 5-minute coffee break coming out to the outside to the right. So feel free to ask any of the team questions during that time. There's also the account abstraction hub, which is in the building over down there to the left. But we'll regroup back here at 11:10. So feel free to go outside, get some coffee, stretch your legs, and we'll be right back. Thank you so much.
Thank you. Thank you, everyone. And we're happy to hear from you. You can connect us on GitHub, Discord, and come ask us questions. And that's it.